now, and I'm going to talk about the stage 1, that is about fluids. Fluids are a state of matter that have specific characteristics. Fluids own the capacity to flow. They are not compressible, but they take the shape of their container and they do not change in volume. Some applications of fluids are water distribution networks, gas distribution networks, and the drainage system. I'm going to talk about pressure. Pressure is calculated by the force that is exerted over the area where the force is exerted. I'm going to talk about the Pascal's principle that states that the pressure exerted on an incompressible fluid flows in the same direction and with the same intensity through all the directions of the container. So this states that force 1 over area 1 is equal to force 2 over area 2, like in this drawing. I'm going to explain this example that says, calculate the force obtained in a larger piston of an hydraulic press whose greater area is of 100 centimeters square and the smaller is 15 centimeters square. Where a force, this is the force 2, is of 200 newtons. So we have already the data here, that is 0.01 meters square. The area 2 is 1.5 times 10 to the minus 3 meters squared, and the force 2 is 200. So we can say that force 1, that is the one we are looking for, over area 1, that is 0.01 meters 2 squared, equals force 2, that is 200 newtons, over the area 2, that is 1.5 times 10 to the minus 3 meters squared. So we're going to calculate this by multiplying these two and dividing the answer over this one. So it's going to be 0.01 meters to the square times 200 newtons over 1.5 times 10 to the minus 3. If we do this in the calculator, we can find out that the force 1 equals 1,333.3 newtons. Thank you.
Hi, I'm Brenda and I'm going to be explaining stage number 2, which is heat and thermodynamics. Some basic concepts you need to know is that heat is represented by the letter Q, and it is known as the energy transferred from a system to its environment when they are at different temperatures. And thermodynamics is the study of heat transformed into mechanical energy. And you also need to know that a system has reached thermal equilibrium when it is at the same temperature. So this is very helpful in heat sources in homes, factories, and companies. You can also use it for environmental cooling in buildings, thermal interchange, and it is very helpful for atmospheric phenomena. So I'm going to be explaining a problem so we can understand better. And in the problem says we have a piece of zinc of 35 kilograms at 51 Celsius degrees. It is placed in a container with water, and the water has a mass of 40 kilograms, and its initial temperature is at 20 degrees. So we're going to find the final temperature of both of the substances. We have the data here, the mass of the zinc, the temperature, and the mass of the water, and the temperature of the water. And we're going to use the formula where Q is heat, as we explained before, and M is mass, C is the specific heat of each material, and this means the change in temperature. And we also need to know that one Q is equal to the other, but one is negative. So here we have already the problem solved. It is we have to equal both of the substances and we have to isolate the TF, temperature final. So at the end we get that the final temperature is 22 degrees and with 30 degrees.
I'm Susana Rodriguez and I'm going to talk about stage 3 that is called electricity. Okay, so some applications of the topic are electric energy generation, which leads to the electric energy sources such as fossil fuels as carbon, gas natural, and petroleum, Also, there is magnetic field generations in overhead cables and household electric circuits. So in this topic, you need to know this constant that is 9 to the 10 times 10 to the 9 and this kind of formula. So the example of this stage is that an electron and a proton are separated by a distance of 2 times 10 to the minus 11 meters. So what's the magnitude of the force applied on the electron? So we know that the electron and the proton have the same amount of energy, electric charge, but with different signs. So these are the values. And also we have the distance, and we need to obtain the force. So we apply this formula. We have these two values substituted and divided times the R, and this is the result, and it's to the right because the result is positive. And that's it.
Hi, my name is Andrea Tames, and I'm going to explain the stage 4, that is wave, sound, and optics. In this stage, we saw different topics, and his applications are sound sources, sound transmission, sound speed, measure of the intensity of the sound, and the optic devices. Okay, we are going to see an example of the Doppler effect. The machinery in a factory produces a sound of 300 Hz frequency. If a person gets close to it at 2 meters per second speed, what frequency does the person gonna hear? The data is this one, the frequency, the velocity of the person, and the velocity of the air. And the formula is this one, and then we are going to substitute the data on this, and it's going to be this 301.76 Hz.